In this video, we're going to be going over how to do all of the calculations that we did in Practice 1, Part 1, except instead of doing them in Excel, we're going to be doing them in SPSS. So the first thing we want to do is open up SPSS. If you're on a Windows computer, you can simply do a search down in the bottom left-hand corner, so you can use like your Start menu and search SPSS. If you are in the virtual lab, the SPSS logo should be on the virtual desktop. And if you're in a Mac, you can use your Launchpad, which is either key F4 that has like 6 squares on it, or you can click on the Launchpad icon at the bottom of your computer. That will open up all of the apps that you have on your computer. You might have to toggle back and forth if you have multiple windows, but SPSS statistics should be listed in your apps. You can click on the SPSS statistics icon, and that will open up the program. I already have mine open, so I'm going to click on my icon. And what you'll notice is a data spreadsheet that kind of looks similar to Excel. And there are 2 views that we have working for us. There's the data view, which is where all of our data goes. Each column represents a variable, and each row represents a subject or a collection. In variable view, this is where we can alter different components of our data, and we're going to do some examples of that in the next couple of videos. What we're interested in doing though for this one is just running what's called a frequencies analysis on the data that we had in our Practice 1 spreadsheet. So let's go to our Excel spreadsheet. We're going to copy all of our data, excluding the student IDs because we don't really need those in SPSS. And then once we are in our data set, you can right-click in the first row, column, cell, and click Paste with Variable Names. Now, just to point out, if you did not highlight this with variable names, then when you get to SPSS, you would just click Paste. Personally, I think highlighting your variable names is a lot easier. So when you copy this information, just make sure you include the labels. Then we can paste with variable names, and you'll see that the variables have now been created in this top row, which represents variables. Right? And then all of our data has been inserted into the rest of the sheet. If we go to variable view, you can see the names of the variables that have been inserted, the type of data, you want this to be numeric, how many decimals are displayed, the labels. This is essentially what is in Excel when you import the data. And you'll notice that all of the symbols that we had in our units of measurement have been maintained, versus in the variable naming area, those symbols have gone away. And that's just because SPSS has limitations on the types of content that can go in the name category. However, the labels, we're kind of unlimited on the type of symbols we can use. We'll deal with this values column in another video. And then on the side here, measure, you have the option of changing your data to scale, which would represent ratio or interval data, ordinal, which is your rank ordered data, or nominal, which is your categorical data. The default in SPSS is to list variables as scale variables. So if this says unknown, you don't have to worry about it because scale is represented by a ruler. And if we go back to our data view, you can see that they've automatically been labeled, our variables have been labeled with a ruler. So thus they have been identified as scale. From here, we can run a frequencies analysis by going to Analyze, descriptive statistics, and frequencies. And within the frequencies, we can choose one or all of the variables. If you're selecting a single variable, you click on it and then click on this blue arrow and it will stick it in the variables area. If we wanted to look at all of the variables, you can click on one variable, press and hold the Shift key, and that will highlight the entire list, and then we can put those in. Alternatively, to move stuff, you can drag it. So if we wanted to remove some variables, we could do it that way. You want to make sure, because we have data that are continuous within this grouping, you want to make sure this display frequency tables is unchecked. If you had this chosen, then we would get frequency distributions for every single value in our data set, which could get kind of messy. So just make sure that display frequency tables box is unchecked. We're going to then click on statistics, and this is where we can choose the types of calculations that we want. So if we wanted to calculate quartiles, we can check this box. If we want a mean, median, mode obviously is only going to be applicable to data that are discrete, meaning they're whole numbers. So our bench 1RM and squat 1RM data would be able to provide us, or SPSS could provide us with a mode, but that wouldn't be so if we were looking at mass, height, GPA, or VO2, because those are continuous. We can look at different measures of dispersion. So in our Excel practice 1, part 1, we had looked at standard deviation, variance, and range. You'll notice that the interquartile range and our coefficient of variation are not options in here. However, you could use the quartile values to calculate the IQR. And then coefficient of variation, if you get the mean and the standard deviation, you can calculate that outside after you get the descriptive statistics. We can also get information about our distribution, so skewness and kurtosis values. We will get a sample skewness and kurtosis as well as the standard error by clicking both of these boxes. So once we have that figured out, we can press continue. And then if we go to charts, you can see we can choose different types of charts to display. If we want a histogram, and we can kind of overlay a normal curve on that histogram just for visual representation, this is one way we can create a histogram plot in SPSS. So then once we have all of that set up, we press OK, and then you'll see an output window pop up. The log has the syntax or the coding for the test, and then on this left toolbar you'll see the output contents. Any of these things that have the little down arrows, if you click on the arrow you can collapse or expand the output contents. Alternatively, you can click on various components and it acts as a shortcut which will pop you down to different parts of your output. Now you'll see some of the times when I click on these different components, it'll become editable, right? So later in the semester, it might be helpful for you to relabel your activities as you do them in SPSS, just to organize them a little bit better. So instead of frequencies, we could list this as practice 1, part 2. And then it would be easier for you to navigate through the side once we start getting into territory where we have longer outputs. But when we click on the statistics portion, we can see all of the descriptive statistics have been calculated for each of our variables. We can see the mean, median, right, everything over here. And then for our quartiles, we have Q1, 2, and 3, or the 25th, the 50th, and the 70th percentile. So if you wanted to use SPSS to calculate your percentiles, and you wanted to calculate an interquartile range after getting this output, you would just do the regular Q3 minus Q1, and you would be able to get the IQR. One thing I want to point out is that skewness and kurtosis, these two are not labeled as sample skewness or sample kurtosis, but that is what they represent. So when we look at our output, we still would need to divide the skewness value and the standard error of skewness, same thing for kurtosis and the standard error of kurtosis. We have to divide these by each other. That way we can get our z-score of skewness and z-score of kurtosis to evaluate distribution shape. So if we took a look at these values compared to our activity 2 data that we calculated, let's take mass for example, right? Our sample skewness was approximately minus 0.3 and our standard error was 0.2. So if we looked at our mass data in here and looked at our skewness, sample skewness is roughly negative 0.3, right? We had our values in our Excel data rounded to the first decimal place, so this would check out. And our standard error was 0.2. Okay. Sometimes the values within or between Excel and SPSS for skewness and kurtosis will be slightly different. I typically will put multiple answers on your exam, so if you're inserting an answer that has been calculated, usually I will have both options for if you calculated it in SPSS versus if you calculated it in Excel. So you can use either method, whichever one seems easiest for you to remember how to use, and then your answer should be logged in the exam. And usually I hand grade those anyway, so if you're pretty close and it's, you know, like a 100th of a decimal off, then I usually will give you points. But again, just a reminder, you would have to calculate these outside of SPSS. So an easy way we could do this is we could copy this table, and let's say we wanted to paste it in Excel. We could then create very quickly 2 rows, right? And then we could do our skewness divided by standard error, right? And then we can copy this across and calculate it for every single one of our variables. So using SPSS is just as easy, in my opinion, as using Excel. Excel, you have to know the equations or the functions. For SPSS, you just have to know how to get to the test and how to insert your equations. But this would be how we would perform our calculations. And just to kind of going a little bit ahead of ourselves, but if you want to take a peek at the histogram, right, this is for VO2. In the top, we can see how many people were included in our sample, our mean and standard deviation. You can see that our units at the bottom, 64.19 is relatively in the center-ish, okay? SPSS automatically creates your axes, so I believe there are ways to edit these, but I probably would never ask you to do that. But we can see from this, by overlaying our normal curve on top of our frequency distribution, that we have a relatively normal data. Okay, same thing if we look at height, GPA, squat, right? So you can kind of mess around with these different functions and have some fun with that. The only other way that we can do these calculations is by doing a means analysis where we do analyze, compare means, and then choose means. And in this one, we can choose, let's say we want to look at mass. And then in the options section, you can choose a list of calculations. So you can see skewness and kurtosis are over here, variance, range, right, our median. We have a little bit of a more limited selection of calculations compared to a frequencies analysis, but this would essentially give us a fairly similar output to a frequencies analysis. The nice thing about the means analysis that's different from frequencies analysis is that we can separate our values by an independent variable, which we don't have in this particular case, but we could separate our values and then get descriptive statistics or all these different calculations based on separated groups instead of kind of clumping all of our data together at once. And that pretty much sums up what we have for part 2. So we'll come back in practice 2 and we'll dive a little bit deeper into the different graphs and plots that you can make both in Excel and SPSS.